Imagine a critical message, vital for a transaction or system update, suddenly failing to process correctly. Without a proper mechanism, this message could be lost forever, repeatedly attempting to process and hogging resources, or even blocking the entire message stream. This scenario highlights a significant challenge in distributed systems, where message delivery and processing must be robust and reliable. Dead letter queues, or DLQs, solve the critical problem of safely isolating messages that cannot be successfully processed by a consumer from the main message stream. They act as a designated holding area for messages that fail delivery after a certain number of retries, are malformed, or encounter unexpected errors, ensuring that these problematic messages do not disrupt the normal operation of your messaging system. The primary reason messages fail relates to issues such as malformed data that a consumer cannot parse, temporary unavailability of a downstream service, or unexpected application-level errors during processing. A DLQ provides a crucial escape route, preventing a single problematic message, sometimes referred to as a poison pill, from continuously being requeued and retried. Without a DLQ, such messages could lead to an endless retry loop, consuming valuable system resources, causing unnecessary alerts, and potentially halting the processing of other valid messages in the primary queue. By isolating these messages, the DLQ maintains the overall health and throughput of your messaging infrastructure. For developers, using dead letter queues involves configuring your primary message queue to automatically send messages to a DLQ when certain conditions are met, such as exceeding a maximum number of delivery attempts. Once messages are in the DLQ, you can implement separate monitoring and alerting systems to notify your team of the failures. This allows engineers to inspect the failed messages, diagnose the root cause of the error, fix the underlying issue in the consumer application or data, and then selectively reprocess those messages from the DLQ back into the main queue or a dedicated repair queue. One insider detail is that DLQs are particularly vital when implementing asynchronous patterns and aiming for high system resilience, complementing concepts like idempotency in message processing. They transform potential data loss and system instability into an opportunity for debugging and recovery. Major cloud providers and messaging systems, such as Amazon Simple Queue Service or AWS SQS, RabbitMQ, and Apache Kafka through its dead letter topic pattern, incorporate DLQ functionality as a core component for building robust and fault-tolerant applications. Ultimately, dead letter queues are an indispensable tool for maintaining data integrity and system stability in complex, message-driven architectures. By providing a structured way to handle and analyze processing failures, they enable developers to build more reliable applications, ensuring that no critical message is truly lost and that operational issues can be systematically identified and resolved, turning potential chaos into controlled recovery.
If this helps you code smarter, like, subscribe, and stay tuned for more.